Okay, so the next thing we will talk about is increasing and decreasing graphs and maxima and minima, relative maximum and minimum. So let's look in. We're going to zoom in on this. A function is increasing over the on an open interval I if f of x is less than f of x2 whenever x1 is less than x2. And so if you look at this, what that says is this x value is less than this x value, so that implies this value is less than that one. And so what that means is from left to right, it has like an upward trend. Okay, and similarly, a function is considered decreasing if whenever this happens, that happens. And so you can kind of see it doing the decreasing one. And then if f of x1 is equal to f of x2, then we consider it a constant. And this is when you have the line y is equal to 1, y is equal to 3, and things like that. Okay. Now, in terms of relative max and min, so let's look at this real quick. Let me draw a graph for you. If I drew the following graph, there is a relative max and a relative min. This is your relative min. This is your relative max. The reason they are not absolute maxes is because there are other points that are taller than these. So anything up here is taller than that, so those could be considered a maximum. But do I call this point the maximum? No, because there's one here. No, because there's one right here, and so on and so forth. And so there is no actual maximum to this graph. And similarly, there's no actual minimum, but there is what we call a relative max and a relative min, and that just means that it's a spot where you could consider it a maximum over an interval. So for instance, if I look at this interval from that part of the graph up to this part of the graph, then yes, this is the maximum for that interval that I'm looking at. And similarly, if I look at from here to here, this is the minimum for that part of the graph that I've done. And similarly, I could put those two into the same thing with these red ones. And that's still a relative min. That's no longer a relative min. The relative min, actually, it's still a relative min, but there are points lower than it. The actual minimum is probably some open point here, but the open max is probably right here. So it would have been nicer if I had drawn it a little bit better, where I did here to maybe there, and then I could say, oh yes, this is the relative max, this is the absolute max, this is the absolute min. Okay, so it's just relative to what you're looking at. And so what I want you to know is that if you look at graphs from left to right, sorry, that's ugly. Would we say this is increasing? Well, I guess that sort of defies this number 1 up here, right? I mean, overall, this is increasing because it starts low here and it gets higher up here and it keeps going higher. But if you look, this point here is an x value. Say let's say that's 2 and this is 4. Well, this y value is like 1.5 and this y value is like 1. And so that breaks this rule up here. So we would say this doesn't follow that increasing. But I would say that overall this is increasing. Because if you were looking at a stock market chart or something, and it looks something like this, if you invested here and you're here today, you would be happy because you probably at least doubled or tripled your money in that time period that this graph did this. And so you would consider it an increase. And so I just wanted to, tell you how I'm going to consider increasing and decreasing for your guys' sake. And so that's increasing, and obviously something more like this, from left to right, it's higher on the left, lower on the right, that would be decreasing. And I think that's pretty common sense, because you know that when graphs sort of do something like this, we would consider that decreasing, which is why this is called decay. So there's that. And then let's look at difference quotient. This is a special formula. It's mainly used in calculus. But what it says is if I give you f of x and I use f of x plus h, and we use that formula, we can find what's called the difference quotient. So let's do that real quick. So if I give you f of x is 2x squared minus x plus 3, then f of x plus h is equal to 2x plus h squared x plus h plus 3. And so if I go ahead and FOIL this, I have 2 times x squared plus 2xh plus h squared. By the way, that's x plus h times x plus h. If you're not sure, just FOIL that out and you'll get this. And then I have minus x minus h plus 3. And so this is 2x squared plus 4xh plus h squared minus x minus h plus 3. Does anything combine? Doesn't look like it. So this is our answer for this. And now for part B of that question above, I'm going to do the f of x plus h minus f of x over h. Well, this thing is this thing, and that is just this. So let's plug all that in and see what it does. So we have 2x squared plus 4xh, h squared minus x minus h plus 3, minus f of x, which is 2x squared minus x plus 3. Yep, okay. And then all over h. So we distribute, this becomes negative, this becomes positive, this becomes negative. And so this one is going to cancel with that one. Let me just write that out for you guys. Sorry. I guess I'm being kind of lazy. So this is going to be 2x, I'm going to rewrite the whole line. 2x squared plus 4xh, h squared minus x plus h plus 3. Minus 2x squared plus x minus 3. Cancel. Positive, negative, negative, negative. 4xh plus h squared plus h all over h. So this is 4x plus h plus 1. And that is your difference quotient. And let me make sure real quick. So this is 4x minus 1. And that's 4x. Uh-oh. Oh, that's a minus. I'm sorry. This should have been minus. I wrote plus there. This should have been minus. So then that turns into minus 1. So this is 4x minus 1 plus h. And there you have it. That is the difference quotient. That is on the homework. Make sure you guys practice this. All I did in this step was 4xh over h plus h squared over h minus h over h. And if you simplify these, you get 4x. That's 1. That's just simply h. So, do your best. Thank you guys.